Ever wondered how robots learn to navigate the unpredictable chaos of real-world tasks? Like what if they're trying to pour coffee but the cup slips? Or they're opening a cabinet but their arm gets stuck? These aren't just robot nightmares, they're real challenges for AI. Today, we're diving into DualTHOR, a groundbreaking simulation platform that's training robots to think on their feet, adapt to surprises, and master tasks even humans find tricky. Let's start with the problem. Traditional robot simulations are like training wheels. They simplify the world too much. They'll let a robot grab a cup perfectly every time. But what happens when the cup is wobbly, the surface is slippery, or the robot's arm gets tangled? In the real world, nothing is perfect. That's where DualTHOR steps in. It's not a tidy playground. It's a virtual stress test designed to mimic the messiness of everyday life. So how does it work? DualTHOR builds on the AI-2 THOR platform, but with a twist. It's all about dual-arm coordination. Imagine a robot with two arms, like a human, trying to do something complex, like opening a cabinet, pouring a drink, or even folding laundry. But here's the catch. DualTHOR doesn't just simulate the task. It introduces chaos. Think of it as a robot's ultimate obstacle course. Here's where it gets cool. DualTHOR uses physics-based simulations to recreate real-world dynamics. That means if a robot spills water, the liquid behaves like real water, splashing, spreading, and even soaking the floor. It also includes inverse kinematics, which helps robots figure out how to move their limbs to achieve a goal. But the real star of the show: contingency mechanisms. These are like built-in what-ifs that force robots to deal with failures. If a cup breaks, the robot has to adapt. If an arm gets stuck, it has to replan. Let's say a robot is trying to grab a glass of water. In a traditional simulator, it might just snap the glass into its grip. But in DualTHOR, the robot might fumble, spill some water, or even drop the glass. These failures aren't setbacks, they're learning moments. The system tracks how the robot responds, teaching it to adjust its strategy in real time. It's like giving a robot a chance to practice dealing with the unexpected, just like we do when we spill coffee or trip over a rug. DualTHOR also uses multi-camera systems to mimic how humans see the world. Think of it as a robot's eyes. First-person cameras on its head give it a 360-degree view, while third-person cameras follow its movements, avoiding blind spots caused by its own limbs. But here's the secret: robots do get the world the way we do. They lack something we take for granted: common sense about how objects behave and how their own bodies work. That's where DualTHOR shines. It's like giving robots a cheat code for real-world chaos. Let's break it down. Imagine a robot in a kitchen. It needs to track object states. Is the mug picked up? Is the cup filled? Is the door closed? These are the robot's way of staying aware. Think of it like a superhero's radar. If the robot tries to grab a full cup, the system predicts spilling before it happens. It's not just smart, it's proactive. But how does a robot even do all this? Enter actions, the robot's skills. There's the simple stuff: move ahead, rotate, or pick. But then there's the cool part: dual-arm operations. Picture this: a robot lifting a coffee machine and grabbing a mug at the same time. It's like juggling, but with precision. DualTHOR lets robots handle tasks that require both arms, like stabilizing a bottle while pouring water. No more one arm is busy problems. But here's the real puzzle: planning. How do you teach a robot to decide when to use one arm versus two? DualTHOR breaks tasks into three categories. There's single-arm work, like picking up a plate. Then there's dual-arm essential tasks, where both arms are a must, like holding a bottle while pouring. And then there's the tricky middle ground: tasks that could be done with one arm, but using both feels more natural. It's like teaching a robot to multitask without overcomplicating things. And let's talk about surprises. In the real world, things go wrong. A drawer might be stuck. A cup might be broken. DualTHOR builds contingency mechanisms, like a robot's what-if brain. If it tries to open a locked drawer, the system might randomly simulate it being stuck, broken, or just working. This variability teaches AI to adapt, because in the real world, nothing is perfect. But here's the twist: even smart AIs like GPT-4o or Gemini-1.5-Pro struggle with this. In tests, they'd plan tasks that assumed both arms could reach a target, but in reality, one arm's range was limited. It's like giving a chef a recipe, but not telling them about the kitchen layout. The AI thinks it's working, but the robot's physical limits trip it up. So what's the solution? DualTHOR isn't just a simulator, it's a training ground. It creates realistic environments where robots can practice dual-arm tasks, learn from mistakes, and build resilience. Imagine a future where robots help in kitchens, hospitals, or even space missions, adapting on the fly, mastering chaos, and bridging the gap between digital intelligence and physical reality. DualTHOR isn't just about robots learning to pour coffee. It's about redefining how AI interacts with the physical world. And as this technology evolves, the line between human and machine will blur in ways we're only just beginning to imagine. Stay curious and keep exploring the frontier of AI.